Hey, Joseph.
Oh, hey, Emil.
What are you up to?
I'm trying to do this project that Anna gave us.
Oh, tell me about it. She's given us like 30 in the past week.
I know, I don't understand.
What is it?
It's a hyperbola.
Oh, yeah, I see. It's a conical section.
Yeah, exactly.
You know, I did the ellipse.
Did you really?
I did.
Wow. You think you might be able to help me with this a little bit?
Sure.
Wow.
I found some chips and some tangerines.
I found some butter tarts and a beautiful looking steak.
Do we have to heat that up?
No, it's beautiful as it is. I like it blue.
It looks kind of red.
Clever.
You know what this reminds me of?
What does it remind you of?
Anna's calculus class.
Really? That's weird.
Yeah? You don't see it?
Actually, I am starting to see a little bit. I'm starting to see that if I were to take this tangerine and I were to throw it up and it comes back down, it's almost like it's a vector. Because as it's coming down, it has both direction and magnitude.
But don't forget, the direction stays the same, but the magnitude changes because the speed increases as it's falling.
That's a good point, Emil. I forgot that one.
But vectors don't always apply to just moving objects. There's a vector between these two tangerines too.
What?
And they're not moving because you have a difference of distance.
Oh, that's true. You know, I think I'm starting to see a couple more examples.
What do you mean?
I mean, if you were to take this tangerine and you were to look at the slope at a given point, it's constantly changing. If you were to change where it is,
You mean like a tangent?
it is almost like a tangent.
It's a tangentarine.
The tangent of the tangerine. Oh my goodness. Do you see anything else, Emil?
Well, kind of looking at these Ruffles chips, it's kind of almost like a parabola, a hyperbola. You know, I read about something. Do you know what it's called? It's like a
Is it a parabolic hyperbola, maybe?
parabolic hyperbola. Yeah.
Is that what they're called?
Yeah. It's like a plane, and you can see it has like a little sine wave on the side.
Oh, that's true. It's almost, yeah. Wow, that's amazing. There are examples of this math all around us. Even when we're eating this dinner, that I had no idea there'd be anything involved in that.
Very healthy dinner.
Yeah. You know, I see a little bit and a little bit of another example.
Example of a plane?
Yes. We can see that actually on this surface, if we look at it as a plane, we can see that we have almost a design, almost like a sine wave going on here along the x-axis and on the y-axis as well. Look.
Oh yeah.
Do you see that too, Emil?
Yeah, it looks like a sine wave on the y-axis.
Yeah.
And a cosine on the x-axis.
Oh my goodness, it does. That's amazing.
That's incredible.
I had no idea. I was just eating these butter tarts. I had no idea there were these sine waves and cosine waves going on. It's a beautiful looking steak.
You know what?
What?
You know what the derivative of a cow is? The derivative of a cow
The
is?
derivative of a cow? How am I supposed to calculate the derivative of a cow, Emil?
It's prime rib.
Oh, prime rib. Oh, that was a good one, Emil. I like that. That was good.
Well, I'm so happy our teacher, Anna Pessoa, is so good that she helps us understand the application of calculus and vectors to the rest of the world. Really, we couldn't ask for a better teacher.
I know, she's by far my favorite teacher.
Very stylish. I love her glasses.
Oh, they bring out her eyes.
Oh, that was a good dinner.
It was a great dinner. What was your favorite part?
Oh, I love the steak.
No way!
It was so delicious.
My favorite part was the steak too.
Really?
It had a really great juicy texture to it. Oh, it was amazing.
Very succulent.
It was excellent. How about a game?
Sure, how about a game of checkers?
Checkers? I love checkers. Oh, here's a nice checkers board.
Imagine that.
Just happened to be sitting there.
How do we start?
I'm not really sure. We have to start placing these checkers somewhere. I'm not really too sure. But you know what I do see, Emil?
What do you see?
I can see that we can actually have a vector between these two checkers pieces because it has a direction of the square root of that squared plus that squared.
Oh, so the components would be 3 right and 1 up.
Exactly. And then do you see any examples of how anything in math class in this board either?
Well, it's also a plane. We could say that these are points on a plane, and we would only need 3 points to define a plane.
Oh my goodness, you're right. Because it then has 2 direction vectors, right?
That's incredible.
What? Wow. Is there what else can you get from that plane, do you know?
I don't know, but I'm never looking at checkers the same way ever again.
No way.
Thank you, Miss Pesovar.
Miss Pesper, you've changed my outlook on life.
Want another butter tart? Last one left.
No thank you. I'm just so full. Full of knowledge. Knowledge from Anna's math class.
God bless y'all. Do you think we'll get extra marks if we keep saying Anna's a good teacher?
I hope so. So we'll have over 100% by now.
I hope so. I need it. I'm sitting at a 42.
You're at a 42? I wish I was at a 42.
You're at a 30?
33.
33.
I
Well,
went up.
almost there.
Almost there.
With our Wednesdays, it's a 79.